Hi, welcome to Physics Teacher. In this grade 11 chemistry tutorial, I'm going to go over an example of gas stoichiometry. Specifically, this is an example that my students would have to calculate in one of the labs that we do. Now, I made a video of that lab, so if you haven't seen it and you'd like to, you can go see it. I've linked it above or in the description. But if you want to see how this problem is done, stay tuned for right after the intro. Alright, so we have a Tums tablet, 1.33 grams Tums tablet, which contains calcium carbonate. And it's going to react with an excess amount of hydrochloric acid. So let's write this reaction. So we're going to have calcium carbonate, which is CaCO3, and that's a solid. And we're going to react with hydrochloric acid, so that's HCl in an aqueous solution. Now what this is going to give us is some carbon dioxide gas. And that's the gas that it's saying it produces. So it produces 95 milliliters of carbon dioxide gas, which is collected over water at STP. So I'm going to talk about this over water in a minute, but let's finish the reaction. So we're also going to get some things that we're not really interested in this sample problem, but let's finish writing this. So we have calcium chloride, and we're going to have some water. Now what I want to do is find the number of moles of carbon dioxide there is. Whenever you're doing stoichiometry, that's a mole to mole ratio. So if I can figure out the number of moles of carbon dioxide, then I'll know the number of moles of calcium carbonate, which is what the question is asking us. It wants to know the percent composition of calcium carbonate in the Tums tablet. Alright, so let's figure out how many moles there are. To figure out how many moles there are, I'm going to use our PV equals nRT, our ideal gas law. And I can solve for N. Now R we know, it's the gas constant. Okay, volume they give us is 95 milliliters, but we're going to put that into liters. So our volume then is going to be 0.095 liters. Now temperature, which it says is STP, would be 0 degrees Celsius. But I'm going to change that to about 20 degrees Celsius because in the actual lab that we performed, that was about room temperature. So let's just change the problem a bit to 20 degrees Celsius. But we're going to need to change that into Kelvin. So what we're going to do is take 20 plus 273, which is going to give us 293 Kelvin. Now pressure at STP, well, the STP for pressure is 101.3 kilopascals. However, this is where that over water becomes important. When we collect a gas over water, we're going to naturally get some water vapor in that gas. So the total pressure, which is 101.3 kilopascals, is going to be comprised of the pressure due to CO2 plus the pressure due to some water vapor. And this is the pressure I want to know. We need to figure out what pressure of water vapor would occur at 20 degrees Celsius. Now this is usually in a table. It's probably listed as a table in your chemistry textbook, or you can look this up online as well. So when you look this up, you're going to see that that pressure at 20 degrees is about 2.3 kilopascals. So now we can solve for the pressure of that carbon dioxide gas as 101.3 kilopascals. Subtract 2.3 kilopascals. And we get a pressure of 99.0 kilopascals. So there's our pressure. So now we know everything we need to know. We know pressure. It's right here. We know volume. It's right here. We know our gas constant. And we know our temperature in Kelvin. So I can rearrange to solve for the number of moles, which will be PV over RT. So pressure is 99 kilopascals times volume 0.095 liters all over our gas constant, which is 8.31 kilopascals liters over moles Kelvin, all times by our temperature, which is 293 Kelvin. So you can check your units. So kilopascals cancel, liters cancels, kelvins cancel, and you're left with per mole, or just moles. And when you punch everything on your calculator, you get 3.86 times 10 to the minus 3 moles. Now, since this is a 1-to-1 ratio here, we also then therefore know the number of moles of calcium carbonate is 3.86 times 10 to the minus 3 moles. Knowing the moles of calcium carbonate, we can figure out the mass of calcium carbonate, where the mass will be the number of moles times our molar mass. And that you're going to have to check on your periodic table, which is actually 100.09 grams per mole. So when we multiply the number of moles times our molar mass, we will get the mass of calcium carbonate, which turns out to be 0.39 grams. And since we want to know the percent composition of calcium carbonate in a Tums tablet, all we need to do to figure that out is take the mass of calcium carbonate inside of a Tums tablet, 0.39 grams, and divide by the mass of that Tums tablet, 1.33 grams, and multiply by 100%. And when we do that, we get the percent composition of calcium carbonate in our Tums tablet as 29.3%. Alright, I hope that helped. If you have any questions, let me know in the comment. If this does help, please subscribe and check out my channel for more tutorials.